Okay, welcome back to sportsciencetutor.com. Now, biomechanics is an area that a lot of undergraduate students seem to find somewhat daunting, and so I want to introduce this area to the sportsciencetutor.com tutorials with a topic that's of interest to me, and that's sprint performance. Now, a key landmark study in terms of sprint biomechanics was produced by Weyand and his team of research back in the year 2000, and their main finding was that the key determinant of maximum speed sprint performance is the magnitude of force that can be produced during a short period of ground contact during the running stride. Now, when we think about Newton's laws of motion and the fact that force equals mass times acceleration, that kind of makes perfect sense. The reason being, the mass of a sprinter doesn't actually change during the course of the race, so we can really remove that aspect away from the equation, which gives us force equaling acceleration. So the more force we can produce, the greater our level of acceleration, and greater levels of acceleration should hopefully ultimately lead to greater levels of maximum sprinting speed. So it kind of does make sense that Weyand found peak force production or high levels of force production during ground contact to be that key determinant of maximum speed sprint performance. But force is a vector quantity, so in addition to that magnitude aspect that we've focused on the previous slide, it also has a directional component. And at this point, I'm going to throw a spanner in the works and tell you that horizontal force production has absolutely nothing to do with maximum speed sprint performance. It's all about how much force we can produce in a vertical direction. So if we want to achieve greater levels of maximum speed sprint performance, we need to be able to produce more force vertically as opposed to horizontally. And at this point, you might be thinking, hold on, what about Newton's third law of motion, which states that for every action there is an equal and opposite reaction? Surely that means if we want to be moving as quickly in a horizontal direction, then we need to be producing as much force as we can in a horizontal direction. At this point, I think it's useful to go back to the idea of acceleration, which is essentially a rate of change in velocity, and therefore acceleration can be defined as rate of change in, or it can be defined as change in velocity divided by time, which means we can express force as mass multiplied by change in velocity divided by time. And that's useful when looking at force from this directional perspective, because in order to produce more force in a horizontal direction, we therefore need to achieve a large change in horizontal velocity. Similarly, if we're interested in vertical force production, then a high level of force being produced vertically is going to require a high level of change in vertical velocity. Now, going back to horizontal force production and change in horizontal velocity, if you think about maximum speed sprint performance, by definition, there is very little change in horizontal velocity because we've reached our maximum capability for sprint speed. We can't get any faster. It's just about maintenance from this point onwards. So if there's very little change in horizontal velocity, there's very little horizontal force being produced. By contrast, there is still a large amount of force being produced vertically when running at maximum speed because we require our center of mass to undergo a large change in vertical velocity during ground contact in order to achieve a sufficient duration of flight phase for each stride. And what's more, the ground contact times have a tendency to get shorter and shorter as we achieve faster and faster running speeds. So when running at maximum speed, we have a large change in vertical velocity in a very short period of ground contact, which means we have very high levels of vertical force being produced. And so there you have it. Maximum speed sprint performance is actually determined by vertical force production as opposed to horizontal force production. Now, the implications of that from the perspective of training interventions is a whole different kettle of fish. And so if that's something that you're interested in looking into more or finding more about, then you may be interested in Mentor, which you can find more about at sportsciencetutor.com.